so let's have a quick conversation about matrices and their inverses and how this fits into our system solving that we want to do with matrices. Okay, so if you were to take a real number, such as 4, you might ask yourself, what do I have to multiply that by to get the multiplicative identity, which is 1? And your answer to that should be 1/4, or the reciprocal. So 4 times 1/4 equals 1. This is the inverse, and this is the identity. So we have the same thing with matrices. So if I were to take a matrix 2, 5, 1, 3, I have a way of finding the inverse so that if I multiply this by its inverse, I will get the multiplicative identity. And the multiplicative identity for a 2 by 2 matrix is 1, 0, 0, 1. If I were to multiply these two together, I would get 2, 5, 1, 3. So this is the multiplicative inverse. So the way we do this, there's a little bit of a pattern for this. The first thing we have to do is define the determinant. So the determinant is found by multiplying on the diagonal, upper left, bottom right, which would be 2 times 3 is 6, and subtract the other diagonal, which would be 5 times 1. So 6 minus 5 equals 1. That's a very nice determinant to have. The fact that the determinant is not 0 means that the inverse exists. If the determinant were 0, it would not exist. So now we can go ahead. So the next step is to take the upper left, bottom right diagonal and switch the members, and then take these two and change the sign, multiply those by a -1, and then the whole thing is divided by the determinant, which in this case is 1, which means it is as it is. So this, if this was A, this would be considered A inverse. So A times A inverse should equal our multiplicative identity matrix. So let's check to make sure it does. So we have 2, 5, 1, 3. And we're going to multiply that by 3, -5, -1, 2. So as we do the math, first row, first column, 2 times 3 is 6. 5 and a -1 is a -5. 6 plus a -5 is 1. First row, second column, 2 times a -5 is 10. 5 times 2 is 10. -10 plus 10 is 0. Second row, first column, 3 times 1 is 3. 3 times a -1 is a -3. 3 plus a -3, 0. And second row, second column, a -5 plus a +6 is a +1. So we have a check there. That means that this is in fact the inverse of that. So where that comes into play is that if we want to solve an equation or a system of equations, and let me give you an easy one. (2x plus 3y equal to 12) and a -x minus y equal to 4, we have 3 different ways of solving this right now. We can either do it by graphing, we can do it by substitution, or we can do it by elimination. We can also do it by creating a matrix equation. All right, and the way that you do this is you take what's called the coefficient matrix, would be like pulling these right off the board. So this becomes a 2, a -1, a 3, a -1, and that will be our coefficient matrix. Those are the coefficients of those variables. And I'm going to multiply that by our variable matrix. And remember, this is okay because this is a 2 by 2 times a 2 by 1, right? And that will give us our constant matrix, which is 12, 4. which is a 2 by 1. And if we remember correctly, these have to match up, and 2 by 1 will be the dimensions of our product. So here we go. Let's just check it. If we take our first row times our first column, we get 2x plus 3y equal to 12. And take this row and this column, negative x minus y equals 4. So this does represent this system. Okay, so here's the trick. If we had something like 2x equal to 6, we know that we want to get 1x, which would give us x, and the way we're going to do that is multiply by the inverse. So that's 1/2. If we multiply this side by 1/2, we must also multiply that by 1/2. Remember, this is the multiplicative inverse, which when multiplied by that will give us the identity, which will give us the variable what we need. So this is 3, obviously, and that's 3. So it's the same idea. Let's let this matrix be A, and we'll call this matrix B. So what we have is this matrix times this equals B. So if we can multiply this by its inverse, that would give us the identity, which would give us xy. But in order to multiply this side by A inverse, we must also multiply that side by A inverse. So what in fact we get is A inverse times A times xy, and because this is a 2 by 2 and that's a 2 by 1, we must put it on this left side. So that means that this is going to be equal to 1, or the identity. We'll call that the identity matrix. So what we get is xy equal to A inverse times B. And this operation is something that we can do by hand, but it's also something that we can do on the calculator by putting A into the matrix function on the calculator, B into the matrix function, and then calculating using the inverse key. And that's something that we did in class, and I believe that's something that they show you in the online textbook. So there you have it. We need to know determinants and inverses in order to write our matrix equations, which allows us to solve any kind of a system using these square matrices.